So I have a Whirlpool microwave here that is not heating. It actually starts, but it doesn't actually heat. Whatever's in there doesn't get hot. And I'm looking at the current draw here. It's drawing 11.3 amps, which is way too low. That tells us the high voltage section is working because it's drawing over 2 or 3 amps, but that the magnetron itself is probably just not emitting the energy that it should be. So we're going to go ahead and replace the magnetron here in this microwave. I'm going to take it down. Of course, we're going to unplug it, and I'm going to discharge that capacitor right there. I took this grill off. There's 2 screws on top. And the grill slides to the left and comes off. You must discharge this capacitor here before doing any work on it. And I recommend that you do not do this unless you're a qualified technician. I will discharge this capacitor. One way that you can discharge a capacitor is a pair of needle nose pliers. Never use more than one hand inside the microwave at any given time. I'm going to touch both sides of the capacitor, and I'm going to make sure the needle nose pliers is actually in contact with each side of the capacitor, each terminal of the capacitor. That will discharge it. A lot of these capacitors have a built-in resistor that will self-discharge the capacitor, but you can't count on that because some of the older capacitors will store over 2,000 volts of a charge, which can kill you, particularly if it goes in one hand and out the other. So that capacitor is discharged. I'm going to take this down. There's one of the retention screws there, and the other retention screw there. I'm going to take those 2 screws out. This whole microwave is going to pivot down, and I'm going to lift it up off of that bracket back there. I'm able to record when I've got a hand free, so I'm not going to be able to record that part of it, but I will record the portion where we are replacing the magnetron. Wave out. It's sitting on a counter. There are screws here, here, here. There are some underneath. Okay, so there's none on the sides. There's some underneath here, and there's some on top. All these screws have to come out. Once I get the screws off, we will lift this cabinet off and expose the magnetron. Okay, I've got all screws out, including those that hold this cover plate on. Cover plate has to come off. And this whole top needs to be pulled out from the sides and pulled backward to release it. Pull backward on it to release it. And the whole cover comes right off. And here's your magnetron right here. This is the part we're going to replace. These are Torx bits, so you need the Torx bit to remove these. You're going to take these 4 out here, these 4 screws out. You're going to need to remove this cover here. The screws that hold this cover on are here, here, and here. So I've already got those out. I'll pull this cover off. I got the 2 screws right there holding the magnetron in. Once I get those out, I can take the magnetron off and I can disconnect the wires. I can put the new magnetron in. Okay, I'm going to just take the screws out that hold this thermal fuse on here. I'm just going to take them and screw them into the new magnetron in the same location and the same holes as correspondingly as it was on the old magnetron. And these two, you want to make sure you observe the polarity. You got to get these on the right way, otherwise these right here, And these two, the same, you're going to take these off, you're going to put them on the same orientation as the old Magnetron. And here's the new Magnetron right here. We're going to put, this is one we're going to put in. Put it in, we're going to reconnect the wires, and we're going to reinstall the thermal fuse, and we're going to put the screws back in. The screws back in the cover, air channel here, and we're going to put it all back together and test it out. Okay, here's one thing I do, and this is what I consider to be a best practice when reconnecting high current connections. A lot of current flows through this filament here, is to take the back half of the connector, slightly squeeze it with needle nose pliers, not the front, the back half of it, so it's tapered when you put it back on. Same with the other one. Slightly squeeze it. So when you put them on, you have a nice tight connection. For high current connections, you need to have a good tight connection, because any kind of substantial resistance in there will cause these high current connections to heat up and eventually burn up from that heat. So we got good, solid, tight connections is what you want on the filament, which is a high current circuit. All right, and we're going to put this back on in the same corresponding holes as on the old Magnetron. I got this one in. I'm going to take this air channel, got it all back together. And one thing that you want to be sure of, other than making sure everything is properly connected the way it was, is that this air channel is properly installed and has a good seal here, because this fan pulls the air through the Magnetron and cools it down, pulls it through that heat sink right there. It's imperative that this is properly installed and sealed well so that it can effectively pull the air through and cool this down, as this gets extremely hot during its operation. Okay, so I've got the microwave cover back on, and I'm going to go ahead and test it before hanging it. It's always a good idea. I've got the kilowatt meter set for current. We should be seeing, whereas we saw about 10 to 11 amps before, I think it was 10 point something amps, which is not right. We should be seeing somewhere between 14 to 17 amps of current draw. That means the high voltage section is not only working, but also that the Magnetron is pulling the proper amount of current, so that your total current draw on the primary side is going to be about within that acceptable range. So I'm going to go ahead and start it here. Cancel. It's asking me to open and shut the door. All right, I'm going to go ahead and press 30 seconds. Press start. All right, let's check the current draw. And we've got 14.78 amps. All right, so that's acceptable. That tells me, I'm going to turn it off. That tells me the Magnetron is working properly. And I'm going to go ahead and finish putting it all back together. I'm going to go ahead and finish putting it all back together. We're going to hang it, test it one more time, and consider it a successful repair. Okay, I've got the microwave all put back together, and let's go ahead and put a coffee cup full of water in there and test it out. This is a coffee cup with 79-degree water in it. Run it for 30 seconds. See, we are drawing 15.8 amps, which is good. Run that for 30 seconds. You notice the current is higher when you have water in there. It's absorbing the energy. I'm going to add a little bit more time to it. Let's just make it 60 seconds. While it's doing that, I just want to mention that, again, this is not a DIY video. This is for appliance technicians learning how to replace magnetrons. This is not something that homeowners should be doing. It is not safe. It is actually a very dangerous repair. This is only for appliance technicians. All right, let's see what we got here. 125 degrees. So it is working. We have successful magnetron replacement on a Whirlpool microwave. That's it for this video. I hope you found it interesting and informative. If so, please give it a thumbs up and subscribe to this channel.